All right, today we're going to be talking about Chapter 5, Lesson 10, Indirect Measurement. So we can use indirect measurement to decide or determine how long a dimension is with something that's difficult to measure. So we're going to use proportions to determine lengths of objects that are difficult to measure. Now, it could be widths, it could be heights, it could be distances, but what we're looking at is using proportions to calculate or determine dimensions that are difficult to measure. So, for example, looking at example 1, it says, suppose the San Jacinto Monument in La Porta, Texas, casts a shadow of 285 feet. At the same time, and that's the key, at the same time, a nearby tourist who is 5 feet tall casts a 2.5-foot shadow. So how tall is the monument? Now, if we look at proportions, again, proportions are ratios that are compared to each other. So the two different kinds of things that are being measured here are shadows and height. So I'm going to be looking at height over shadow equals height over shadow. This first one is going to be the person, and the second one is going to be the monument. So the height of the person was 5 feet tall, and the shadow that they casted was 2.5 feet. The height of the monument is, we don't know. But the shadow that it cast was 285 feet. So now that I have my proportion, I'm going to use cross products to help me solve. So 2.5 times h is 2.5h, and 5 times 285 is going to give me 1,425. To figure out what the height of the monument is, I have to divide both sides by 2.5. Now let's see that the height is 470 feet. So the monument is 470 feet tall. Again, proportions are incredibly helpful for finding little pieces of information that we don't know, but we do know other pieces of information that help us figure it out. Again, we knew both shadows and we knew how tall someone was, so we can figure out how tall the monument was. The key, again, was at the same time. If it was not at the same time, the shadows might be different lengths. And we don't want that because we want to see at the same time. If it wasn't at the same time, the sun could be in different locations, casting different size shadows. Now, example 2, we can also use it to help survey. Now, surveyors use this kind of calculation to determine how long something is for something that they really can't figure out. For example, how wide the lake is at this point. Now, they could get a tape measure, but looking at the other dimensions, they're all in miles, this would be an incredibly long tape measure. So they're going to use indirect measurements. So it says, in the figure, triangle PQT is similar to triangle PRS. This sign right here, this symbol, means similar. So it says find x, which is the distance across the lake. We're going to use proportions again. We're going to look at similar figures. So this triangle here, PQT, says is similar to PRS, which is good to know. Whenever we see how shapes are named, that means P is where we start, we go through Q, and we make it to T. So we start at P, go through Q, make it to T. Same with this one. We start at P, we go to R, and end at S. So this 25 and 60 are corresponding. They're in the same place on different parts of or different triangles. So I'm going to use that information, 25 over 60. Now the X and 12, those are also in the same location on different shapes. I use the smaller shape first, so I'm going to use the smaller shape again first, and then over X. Use cross products to help me solve this proportion. So I have 25 times X, which is 25X, and I have 60 times 12, which is going to get me 4,000. Not 4,000, 720. Now, in order to find out what X is, I have to divide both sides by 25. And 720 divided by 25 gets me X equals 28.8 miles. So the distance across the lake at that point is 28.8 miles, which would make for a very, very long tape measure. So proportions can help figure out difficult to measure dimensions because they're either incredibly small or incredibly large. So if you have any questions, please let me know. Otherwise, this is the end of Lesson 10.